Application of integrals. Let us do exercise 8.2. Question number 1. Find the area of the circle 4x square plus 4y square is equal to 9, which is interior to the parabola x square is equal to 4y. And this is quadratic in x and y with same coefficients, so it represents a circle. 9 by 4 can be written as 3 by 2 the whole square. Center of this circle is 0, 0 and the radius is 3 by 2 units. And this is a parabola, upward parabola, because positive y. Now let us solve these two equations. Substitute for x square in the circle equation. 4 times x square is 4y plus 4y square is equal to 9. We get a quadratic equation in y. Product is minus 36, sum is 16. So the numbers are 18 and minus 2. Let us split the middle term. From the first two terms, 2y is common. From the next two terms, minus 1 is common. Therefore, the factors are 2y minus 1 times 2y plus 9 equal to 0. We get two solutions, y is equal to half and y is equal to minus 9 by 2. Let us calculate the corresponding x coordinates. Both are quadratic in x, so we can use any one of these two equations. Let us use x square is equal to 4y. X square is 4 into half, which is 2. Therefore, x is plus or minus root 2. Here x square is 4 times minus 9 by 2, which is minus 18, not possible. The reason is square of a number cannot be negative. Therefore, the points of intersection are write the x coordinate first, plus or minus root 2, comma half. Let us draw the figure. The radius of the circle is 3 by 2 units. And this is 1, so half will be here. So corresponding to half, we have points on the circle. This is plus root 2 comma half and this is minus root 2 comma half. The parabola passes through these 2 points of intersection and the origin. We have 3 points to complete the parabola. Let us write the equations of these two curves. Parabola equation is x square is equal to 4y and the circle equation is x square plus y square is equal to 3 by 2 the whole square. And we have to shade the region. Both parabola and circle are symmetric about y axis. So we will calculate one area and multiply it by 2. The shaded region is between two curves. So we will do upper curve minus lower curve with respect to x, or we may do with respect to y also. Let us find the area with respect to y. So area is equal to, we will take this as A area and this is B area. So 2 times A plus B, which is equal to 2 times area A is under the parabola and the limits are 0 to half. We are doing with respect to y, therefore we have to write the y limits. Integral 0 to half of x of parabola into dy. We are doing integration with respect to y variable, plus b area is integral. The limits for y variable are half to 3 by 2. X of circle equation into dy, which is equal to 2 times integral 0 to half of x from the parabola equation. X is 2 times root y dy plus integral half to 3 by 2 of x from the circle equation is root of 3 by 2 the whole square minus y square dy. 2 times 2 into integral of y power half is y power 3 by 2 into 2 by 3, and the limits are 0 to half, and this formula is y by 2 root of 9 by 4 minus y square plus a square by 2. A square is 3 by 2 the whole square, which is 9 by 4, and the formula has divided by 2 sine inverse of y divided by 3 by 2, and the limits are half to 3 by 2. Here also the limits are half to 3 by 2, and 2 is common for all these three terms. 2 times 4 by 3 into half power 3 by 2, that is 1 by 2 power 3 by 2 minus 0, plus upper limit will give you 0, 9 by 4 minus 9 by 4. Lower limit will be y is half, half by 2 is 1 by 4 root of 9 by 4 minus half square plus 9 by 8 times sine inverse of 2 by 3 into 3 by 2 will become sine inverse of 1 minus sine inverse of 2 by 3 into half will be 1 by 3. Distribute this to 8 by 3 times 1 by root 2 cube is 2 root 2 minus distribute to 2 by 4 times 8 by 4 is root 2 plus 9 by 8 times, and we have to distribute 2. So, it becomes 9 by 4 times pi by 2 minus sine inverse of 1 by 3. Let us cancel root 2. So, we get 2 root 2 over 3 minus root 2 divided by 2 plus 9 by 4 times pi by 2 minus sine inverse of 1 by 3. These two are like terms. Take LCM 6. So, we get 4 root 2 minus 3 root 2 plus 9 by 4 times pi by 2 minus sine inverse of 1 by 3, which is root 2 divided by 6 plus 9 by 4 times pi by 2 minus sine inverse of 1 by 3 can be written as cos inverse of 1 by 3 square units. Or you may change cos inverse of 1 by 3 to sine inverse of 2 root 2 by 3. Second question, find the area bounded by the curves x minus 1 the whole square plus y square is equal to 1 and x square plus y square is equal to 1. Both are circles. This circle center is 1, 0. This is of the form x minus h the whole square plus y minus k the whole square equals r square, and radius is 1 unit, and here center is 0, 0 and radius is 1 unit. They are congruent circles because their radii are same. Let us solve these two equations. From the first equation, y square is 1 minus of x minus 1 the whole square. From the second equation, y square is 1 minus x square. We can cancel minus sign also. X minus 1 the whole square is x square. Let us open the brackets. X square minus 2x plus 1 is equal to x square. We get 2x is equal to 1. Therefore, x is half. Let us substitute in one of these two circle equations. Y square will be 1 minus half square, which is 3 by 4. Therefore, y will be plus or minus root 3 over 2. Therefore, The points of intersection are half comma plus or minus root 3 divided by 2. For the first circle, the center is at 1 comma 0 and radius is 1 unit. So, it passes through the origin as well as this 2 comma 0 point. Let us write the equation of the first circle, x minus 1 the whole square plus y square is equal to 1. Now, for the second circle, the center is at the origin and radius is 1 unit. The equation is x square plus y square is equal to 1. And the point of intersection is half comma root 3 by 2. This is half comma minus root 3 divided by 2. Let us draw the limit line. This is half. This is the area to be calculated and it is symmetric about x axis. You will find one area and multiply it by 2. An integration we are going to do with respect to x axis. Let us take this as area A and this as area B. Therefore, the required area will be 2 times A plus B. 2 times area A is under the first circle and the limits are 0 to half. So, integral 0 to half of y of the first circle is 1 minus x minus 1 the whole square dx from this equation, and then plus B area. B area is under the second circle and look at the limits half to 1. So, integral half to 1 of y from the second circle is root of 1 minus x square dx. Let us use the formula 2 times, here x is x minus 1. So, x minus 1 by 2 root of 1 minus x minus 1 the whole square plus a square by 2 sine inverse of x, here is x minus 1 by a is 1 and the limits are 0 to half, plus the same formula for the next integral, which is x by 2 root of 1 minus x square plus a square by 2 sine inverse of x by a is 1 and the limits are half to 1. Now, we have 2 common. Let us cancel 2 throughout with the 2 which is outside. Substitute the limits. Half minus 1 is minus half, root of 1 minus half minus 1 is minus half the whole square, which is 1 by 4, and lower limit 0 minus 1 is minus 1 and here it will be 1 minus 1 which is 0. So, 0 into minus 1 is 0 plus sine inverse of half minus 1 which is minus half minus lower limit sine inverse of 0 minus 1 is minus 1 plus the next term 1 minus 1 will become 0 upper limit, lower limit is x into, that is half into root of 1 minus half square, 1 minus 1 by 4 is 3 by 4 plus sine inverse of 1 minus sine inverse of half. So, this term is minus half into root 3 by 2. Sine inverse of minus x is minus sine inverse of x, therefore, it becomes minus sine inverse of half. Similarly, this will be minus of minus plus sine inverse of 1 minus half into root 3 divided by 2 plus sine inverse of 1 minus sine inverse of half. As they are congruent circles, A area and B area will be equal. Look at the answer. See, these two are equal. Same terms we have got. Therefore, I can write this as 2 times minus root 3 divided by 4 minus sine inverse of half is pi divided by 6 and sine inverse of 1 is pi divided by 2, which is 2 times pi by 2 minus pi by 6 is pi by 3 and minus root 3 divided by 4 Therefore, the answer is 2 pi by 3 minus root 3 divided by 2 square units. In this, area A and area B will be equal as the circles are congruent, but only when they are symmetric about x axis and y axis we do into 2 or into 4. Okay, here this dotted line is not x or y axis, that is why we are not doing 4 times A area or 4 times B area. Only when the area is symmetric about x or y we do into 2. Question number 3. Find the area of the region bounded by the curves y is equal to x square plus 2, y is equal to x is equal to 0 and x is equal to 3. This parabola is not in the standard form. Let us solve these two equations. X square plus 2 is equal to y, where y is x. Therefore, we get a quadratic equation in x. And here discriminant is b square minus 4ac, which is minus 1 the whole square is 1, minus 4 into 1 into 2, which is 8 negative. So, we do not have real roots. What does it mean? That means these two curves are not intersecting each other. There is no point of intersection. Now, let us solve the parabola and x is equal to 0. So, if we substitute x as 0, y will be 2. Therefore, the point of intersection for these two curves is 0, 2. Let us substitute x is equal to 3 in the parabola equation. Therefore, y will be 9 plus 2, which is 11. The point of intersection is 3, 11. And here if you see the parabola equation, y is equal to x square plus 2. So, positive y axis is the axis of the parabola, but vertex will not be at the origin. I told you this is not in the standard form. 0, 2 is here and 3, 11 is here. So, symmetrically the other point will be on this side. So, let us complete the parabola. The parabola does not pass through 0, 0. Here the vertex is at 0, 2. Write the equation of the parabola. Y is equal to x square plus 2. Now, y is equal to x line is easy to draw. For y is equal to x, if x is 0, y is 0. If x is 2, y is 2. So, 0, 0, 2, 2 is here. Let us join these 2 points. This is y is equal to x line. X is equal to 0 is the equation of y axis and x is equal to 3 is a line parallel to y axis. This is x is equal to 3 line. Let us shade the region, area of the region bounded by these 4 curves. So, this is the area. These vertical lines x is equal to 0 and x is equal to 3 will become the limit lines. I am going to do the integration with respect to x axis. The area is between two curves, between parabola and the line. So, we will be doing upper curve minus lower curve. Therefore, the required area is equal to integral. For the parabola, the limits are 0 to 3 and for the line also the limits are 0 to 3. 0 to 3 of upper curve is parabola with respect to x. So, y dx minus we have to subtract. For line also the limits are 0 to 3, y of line equation into dx. Let us substitute for the variable y. From the parabola, y is x square plus 2. Integral 0 to 3 of y from the line equation is x dx. Let us integrate x cube over 3 and the limits are 0 to 3. Integral of 2 is 2x, the limits are 0 to 3. If you have parabola and line, the integration is so easy. Only for circle and ellipse you will get integral root of a square minus x square formula. This is x square over 2 and the limits are 0 to 3. Let us substitute the limit values. 2 cube is 27, lower limit is 0, 2 times 3 minus 0 minus half into 3 square is 9, lower limit is 0. 27 divided by 3 is 9, 2 3s are 6 minus 9 by 2, which is 15 minus 9 by 2. Take LCM. The answer is 21 divided by 2 square units. Question number 4. Using integration, find the area of the region bounded by the triangle whose vertices are minus 1, 0, second vertex is 1, 3 and the third vertex is 3, 2. Let us name the vertices as A, B, C. To do integration, we need the equations of these sides. So, we are going to use 2-point form of a straight line. I am writing the equation y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. This is the 2-point form of a straight line. Let us find the equation of AB. A is minus 1, 0 and B is 1, 3. We will take this as x1 y1 and this as x2 y2. Let us use 2-point form. Y minus y1 divided by y2 minus y1 is equal to x minus of minus 1. So, plus 1 divided by 1 plus 1. Y divided by 3 is half into x plus 1. Therefore, y is 3 by 2 times x plus 1. This is the equation of AB. Now, let us find equation of BC. B point is 1, 3, C point is 3, 2. Let us take B as x1, y1, C as x2, y2. You may interchange and take also, does not matter. Y minus y1 divided by y2 minus y1 is equal to x minus x1 by x2 minus x1. We get y minus 3 divided by minus 1 is equal to x minus 1 divided by 2. Y minus 3 is 1 minus x divided by 2. Y is 1 minus x divided by 2 plus 3. Let us take LCM. 1 minus x plus 6. Therefore, the equation is y is equal to half into 7 minus x. Similarly, the third equation, equation of AC. A point is minus 1, 0 and C point is 3, 2, x1, y1, x2, y2. Let us find the equation using 2-point formula. Y minus y1 divided by y2 minus y1 is equal to x minus x1. So, minus of minus will become plus 1 divided by x2 minus x1, which is y by 2 is equal to x plus 1 divided by 4. Therefore, the equation is y is equal to half into x plus 1. We found all the three equations. Drawing the figure is so easy because the three vertices are given. The first vertex A is minus 1, 0. The second vertex is 1, 3, which is B. And the third vertex C is 3, 2. Let us join these 3 points. This is AB line. Let us write the equation of AB, which is y is equal to 3 by 2 times x plus 1. The equation of BC is y is equal to half into 7 minus x. And the equation of AC is y is equal to half into x plus 1. Shade the region. This is the area to be calculated. we will draw the limit lines. For the line segment AB, with respect to x, the limits are -1 to 1. Therefore, area of the triangle will be integral for the line segment AB. The limits are -1 to 1 of y of AB line we have to write. Then under the curve BC, so plus the limits for BC line are 1 to 3 y of BC line dx, and minus the lower curve. Here we have two upper curves, AB and BC, and we have one lower curve. So, always to find the triangular region, take the upper curves, add them and subtract the lower curve. In some triangles you may have one upper curve and two lower curves. So, in that case upper curve minus these two lower curves you have to do. Here we have only one lower curve which has to be subtracted. Integral the lower curve AC, look at the limits, -1 to 3 of y of AC line. Let us substitute for y. -1 to 1 of equation of AB is 3 by 2 times x plus 1 dx plus integral 1 to 3 of y of BC line half into 7 minus x dx minus integral -1 to 3 of AC equation, which is half into x plus 1 dx, and integration is so easy. X square divided by 2 and integral of 1 is x, the limits are -1 to 1, plus the second term half into integration of 7 is 7x and minus integral of x is x square over 2, and the third term half into integral of x is x square divided by 2 and integral of 1 is x. Now, let us apply the limits. 3 by 2 times half into upper limit minus lower limit. Lower limit is -1 the whole square, which is 1. Upper limit minus of -1 plus half into 7 times 3 minus 1 minus half 3 square 9 minus 1 half into 3 square 9 minus of -1 the whole square is 1 and 3 minus of -1. This term is 0 and that becomes 2, half into 7 2s are 14 minus 8 by 2, 8 by 2 is 4 minus half into 8 by 2 is 4 and that is 4. We get 3 plus 10 by 2 is 5, 8 by 2 is 4. We can easily check our answer. First area is 3, that is area of triangle. I will name these points as M and N. See, this is area of triangle ABM. You can use half BH formula. Half into base is 2 units and the height is 3 units. See, we got 3. And this area is a trapezium under BC, BCNM. Area of a trapezium formula is half h into a plus b. H is the distance between the parallel sides, which is 2 units. A and B are the lengths of the parallel sides, 3 plus 2, 5. That is also correct. This is area under the curve AC, which is a right triangle. Half into, that is area of triangle ANC. Half into base is 1, 2, 3, 4 units into height is 2 units. So, we got 4. So, all 3 answers are correct. So 8 minus 4, which is 4 square units. We cannot directly use these formulae to calculate the area, because it will be mentioned in the question, using integration find the area. The answer is 4 square units. Question 5. Using integration find the area of the triangular region whose sides have the equations y is equal to 2x plus 1, y is equal to 3x plus 1 and x is equal to 4. So, this is also a triangle question, but in the fourth question vertices were given, we had to find the equations. Here equations are given, so we will find the vertices. Number the equations 1, 2 and 3. Let us solve 1 and 2. Both are y, let us equate them. Therefore, we get x is equal to 0. If x is 0, y will be substitute in the first equation or in the second equation, we get 1. Therefore, 0, 1 is one point of intersection. Now, let us solve second and third. X is 4, y will be 4 3s are 12 plus 1, which is 13. The point of intersection is 4, 13. Now, let us solve 1 and 3. X is 4 and y is 2 4s are 8 plus 1, which is 9. Therefore, the point of intersection is 4, 9. We will name the points A, B, C. Let us draw the figure. On the y axis, we need 13 units. Let us plot these points. 0, 1. This is vertex A. This is B 4, 13 and C 4, 9. Let us join these points. A, B line. So, the common number is 2. So, equation 2. This is y is equal to 3x plus 1. Let us join BC, and equation of BC line is x is equal to 4. Join AC and it represents the first line. Y is equal to 2x plus 1, or you may draw the tables and draw the lines and find the points of intersection from the graph. Let us shade the region. Area of the triangle has to be calculated. So, x is equal to 4 becomes the limit line and the other line is y axis. Now, we have to find the area between two curves. This is the upper curve and this is the lower curve. I told you x is equal to 4 becomes the limit. Therefore, area is equal to integral. Look at the limits for the upper curve. I am going to do integration with respect to x axis. So, the limits for upper curve is 0 to 4, for the lower curve also 0 to 4. So, 0 to 4 of upper curve equation is 3x plus 1 minus lower curve equation is 2x plus 1 times dx. Both are linear, so I wrote it under one integral because the limits are equal. We can simplify the function. 3x minus 2x is x and 1 gets cancelled. The function becomes so easy. Now, integral is half into x square, the limits are 0 to 4, half into upper limit is 4 square, which is 16, lower limit is 0 square. The answer is 8 square units. And using mensuration formula, you can calculate the area and check the answer. Question number 6. Choose the correct answer in the following exercises 6 and 7. Smaller area enclosed by the circle x square plus y square is equal to 4 and the line x plus y is equal to 2. This circle center is 0, 0 and radius is 2 units. And this line makes intercepts 2 on the x axis and 2 on the y axis. So, we will solve the equations. X square plus, for y we can substitute 2 minus x, Therefore, it becomes 2 minus x the whole square is equal to 4. Let us expand. Two x square minus 4x is 0. 2x is common. We get x is equal to 0 as one solution and x is equal to 2 is the other solution. Let us calculate y values. Substitute in the line equation because you have linear y, whereas the circle equation has y square. So, do not select that, use line equation. Y is 2 minus x. Therefore, y will be 2 minus 0 which is 2, and if x is 2, y will be 2 minus 2 which is 0. Therefore, the points of intersection are 0, 2 and 2, 0. The radius is 2 units and the center is at the origin, and the line passes through 0, 2 and 2, 0. This point is 0, 2 and this point is 2, 0. Join these 2 points. Draw a neat figure, use scale and pencil to draw the diagram and use compass to draw the circle. Now, let us shade the region. We have to find the smaller area enclosed by the circle and the line. Let us shade the smaller region between the circle and the line. This is the area to be calculated. We can calculate with respect to y or with respect to x. Let us do with respect to x. And the area is between two curves. So, we have to do upper curve minus lower curve. Therefore, area is equal to, and the limits for both the curves are 0 to 2 with respect to x. So, integral 0 to 2 of upper curve is circle minus integral 0 to 2 of lower curve is the line. Let us substitute integral 0 to 2 of y from the circle equation, which is square root of 4 minus x square, which is 2 square minus x square dx, minus integral 0 to 2 of y from the line equation, which is 2 minus x dx, x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. Let us write the limits. Minus 2 into integral of 1 is x and the limits are 0 to 2, and do not forget to distribute this negative sign. Minus of minus is plus. Integral of x is x square divided by 2. Let us substitute the limits. Upper limit will give 0, 4 minus 4. Lower limit is 0 because you have x. 2 times sine inverse of 2 by 2 is 1 minus sine inverse of 0 is 0, and 2 times 2 minus 0 plus half into 2 square minus 0. 2 into sine inverse of 1 is pi by 2, sine inverse of 0 is 0, minus 4 plus 2. Therefore, the answer is pi minus 2 square units. And the correct option is B. Question number 7. Area lying between the curves y square equal to 4x and y equal to 2x. Y square equal to 4x is a right side parabola. Y equal to 2x is a straight line passing through the origin because there is no constant term. Let us solve these two equations. Substitute for y. 2x the whole square is 4x. 4x square is 4x. Cancel 4. X square minus x is equal to 0. You can cancel x also, but don't forget to equate it to 0. Or factorize and do it. So, we get two answers, x is equal to 0 and x is equal to 1. So, to find y value, let us use the line equation because it is linear in y. If you use parabola equation, you will get y square, plus or minus sign will be there. One answer will be correct, one will be wrong. You have to check. It is better to use the linear y equation. So, y is equal to 2 times 0, here y is equal to 2 times 1. Therefore, the points of intersection are 0, 0 and 1, 2. Now, let us draw the figure. The parabola passes through 0, 0 and 1, 2. Symmetrically, we can take 1, minus 2 also. Let us complete the parabola. This is y square is equal to 4x, and y is equal to 2x line also passes through these 2 points. Let us join these 2 points to get the straight line. Write the equation of the straight line, which is y is equal to 2x. Now, the area is between these two. Shade the region. The limit line is this, and for both the curves the limits are 0 to 1 if it is done with respect to x. So, upper curve minus lower curve. Upper curve is parabola, lower curve is the line. Therefore, area is equal to integral 0 to 1 of upper curve, which is y of parabola, minus the lower curve. For lower curve also the limits are 0 to 1. Lower curve is line. So, y of line dx. Let us substitute. Y from parabola equation is root of 4x, which is 2 root x dx. Integral 0 to 1 of y from the line equation is 2x dx. The integration is so easy. X raised to 3 by 2 divided by 3 by 2, which is into 2 by 3. The limits are 0 to 1, minus 2 times x square divided by 2. The limits are 0 to 1. 4 by 3 times 1 power 3 by 2 is 1, 0 power 3 by 2 is 0, minus 1 minus 0. 4 by 3 minus 1. The answer is 1 by 3 square units. Therefore, the correct option is B. Example 7. Find the area lying above x axis and included between the circle x square plus y square equal to 8x and inside of the parabola y square equal to 4x. Let us solve these two equations substituting for y square, which is 4x. X square minus 4x is equal to 0. Let us factorize. X times x minus 4 is 0. We get two answers for x. X is equal to 0 and x is equal to 4. Let us find the corresponding values of y. In y square equal to 4x, y square is 0. Therefore, y is 0. If x is 4, y square is 4, 4s are 16. Therefore, y will be plus or minus 4. The points of intersection are 0, 0 and 4 plus or minus 4. Let us write the circle equation in the standard form. X square minus 8x plus y square equal to 0. Let us complete the squares. X minus 4 the whole square minus b square term, which is 4 square, plus y square is 0. X minus 4 the whole square plus y square equal to 4 square. We have written this circle equation in the form x minus h the whole square plus y minus k the whole square equal to r square. Therefore, center of the circle is 4, 0 and radius of the circle is 4 units. Let us draw the figure. The radius of the circle is 4 units. Therefore, this is 8 and the points of intersection are 0, 0 and this point is 4, 4 and this point will be 4, minus 4. The parabola is a right side parabola passing through these 3 points. Write the parabola equation. Y square is equal to 4x and the circle equation is x minus 4 the whole square plus y square equal to 4 square. The area is lying above x-axis and included between the circle and inside of the parabola. The limit line is this. Therefore, the required area is area A plus area B. Area A is under the parabola between the limits 0 and 4. Therefore, it is integral 0 to 4 y of parabola dx plus B area is between the limits 4 and 8. Integral 4 to 8 area is under the circle. Therefore, y from the circle equation times dx. Integral 0 to 4 from parabola equation y is root of 4x which is 2 root x dx plus integral 4 to 8 y from the circle equation is root of 4 square minus x minus 4 the whole square dx. 2 times integral of root x is x raised to 3 by 2 times 2 by 3 and the limits are 0 to 4 plus the formula x minus 4 divided by 2 root of 4 square minus x minus 4 the whole square plus a square divided by 2 sine inverse of x, that is x minus 4 divided by a is 4 and the limits are 4 to 8. 4 to 8. 4 divided by 3. Upper limit is 4 raised to 3 by 2 minus lower limit is 0 plus upper limit will be 0 because 8 minus 4 is 4, 4 square minus 4 square 0. Lower limit is 0 because this term becomes 0 plus 8 times sine inverse of 8 minus 4, 4 by 4 is 1 minus sine inverse of 4 minus 4, 0, 0 by 4 is 0. 4 divided by 3, 4 raised to half is 2, 2 cube is 8 plus 8 times sine inverse of 1 is pi by 2, sine inverse of 0 is 0. 32 over 3 plus 4 pi. By taking 4 by 3 out, we can write it as 8 plus 3 pi square units. Example 8. In the given figure, AOBA is the part of the ellipse 9x square plus y square equal to 36 in the first quadrant such that OA is equal to 2 and OB equal to 6. Find the area between the arc AB and the chord AB. The given ellipse equation is 9x square plus y square equal to 36. We will write it in the standard form. Let us divide by 36. X square divided by 4 plus y square divided by 36 is equal to 1. X square by 2 square plus y square divided by 6 square equal to 1. The ellipse passes through A and B. To do integration, we need equation of the chord AB. We will use 2-point form. Equation of chord AB using 2-point form. Y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. We will take A point as x1 y1 and B point as x2 y2. Y minus 0 divided by 6 minus 0 equal to x minus 2 divided by 0 minus 2. Y will be 6 divided by minus 2 times x minus 2. minus 3 times x minus 2. Y is minus 3x plus 6. This is the equation of the chord AB. Now we will find the area. Area is between two curves, so we have to do upper curve minus lower curve. We will do integration with respect to the variable x. For both the curves, the limits are 0 to 2. Therefore, integral 0 to 2 of upper curve is ellipse dx minus integral 0 to 2 of lower curve is the line dx. The ellipse equation is 9x square plus y square equal to 36, from which y square is 36 minus 9x square. Take 9 out, 4 minus x square. Y will be, we need not write plus or minus sign because we are using the curve in the first quadrant. Y is 3 times root of 2 square minus x square. Therefore, we get integral 0 to 2 of 3 times root of 2 square minus x square dx minus integral 0 to 2 of, from the line equation, y is minus 3x plus 6 times dx. We will integrate. The formula is x divided by 2 root of 4 minus x square plus a square divided by 2 sine inverse of x divided by a, and the limits are 0 to 2, 0 to 2. Minus of minus is plus 3 times integral of x is x square over 2, and the limits are 0 to 2. And don't forget to distribute the minus sign. It becomes minus 6. Integral of 6 is 6x, and the limits are 0 to 2. 3 times upper limit will become 0, 4 minus 4, and lower limit is also 0 because of this x, plus 2 times sine inverse of 2 by 2 is 1 minus sine inverse of 0 by 2 is 0, plus 3 by 2 times upper limit 4, lower limit 0, minus 6 times upper limit minus lower limit 2 minus 0. 3 2s are 6. Sine inverse of 1 is pi by 2, sine inverse of 0 is 0, and plus 3 2s are 6 minus 12. 3 pi minus 6 square units